Dear master students, welcome to this introduction into the world of digital research databases. It will be brief, but it has the potential to change your life forever and for the better. And that's not even a joke, as semantic data become more and more a requested outcome of research. So we are talking about funding and money. I guess that each one of you has already experience in creating an Excel table for statistical research data. That's a good start, but not a database yet. In order to understand how modern semantic databases work, it's first important to get to know the three most important basic terms. These will be briefly explained here and then further discussed on the example of the De Jonge Wiki, a database on the building history of the Arenberg Castle. Our first element here is the knowledge graph. It is the basic structure to express a statement in a semantic database. In order to formulate such a statement, we need two basic building blocks. On the one hand, these are standardized entities, and on the other hand, standardized properties. A connection of two entities through a property is called a knowledge graph. So entity A is related to entity C through the property B. Data scientists also speak of nodes instead of entities and edges instead of properties. The resulting connection of three elements is called a semantic triple. These semantic triples are the basic building blocks of a semantic database. A simple structure that can be expressed by such relationships is a biological taxonomy. That is a hierarchical classification system in which the various entities are related to one another by the properties is part of or vice versa contains. A human being is a mammal in the category of skeletal animals, which in turn belongs to the category of animals and so on. The relationships are a little more complex in the game Rock, Paper, Scissors, Lizard, Spock from the TV series Big Bang Theory. The five entities form a network with the property is superior or the other way around is inferior. In more complex relationship systems, such as this example from art history, the various entities are connected to knowledge graphs by a variety of properties. We learn that Lily, who is interested in Da Vinci, is friends with James, who likes the Mona Lisa, on display in the Louvre, and so on. The second basic concept is the authority data. Authority or normative data is important to uniquely describe and identify an entity. Let's take Tom Jones as an example. These two words refer to a pop singer, a football player, a baseball player, a novel, or a movie, among other things. In order to accurately determine that the Tom Jones we are interested in our example is the pop singer, we need a more specific attribution, such as is possible with authority data. There are already a large number of classification systems that create norm data for the relevant era. In the USA, for example, the Library of Congress name authority files. In Germany, the Gemeinsame Normdatei. In France, the Système Universitaire de Documentation. Or across countries, the Virtual International Authority file. Other standardization systems include the ISBN number for books, the Nomisma for coins, or the ULAN for artists. Our Tom Jones is identified in the GND by the file number 1188958777, in the LCNAF by the number N5004196, and by the VF number 3771466. The Wikimedia Foundation that you all know from Wikipedia has its own authority data system that is organized through the platform Wikidata. Here, entities are referred to by a Q number. Our singer Tom Jones, for example, is referred to by the identifier Q180850. That means that he was the 180th, 850th entity that was listed here. As a small assignment, you can look if you can find information on your Professor Thomas Kuhlmann's on Wikidata. In order to bring together all the authority data systems already mentioned, Wikidata also lists all those other identifiers of an entity. In our example, the list begins with the VIAF, followed by the International Standard Name Identifier, and the classification system of the Vatican Library. The full list of identifiers from other systems for Tom Jones listed on Wikidata is shown to the right, showing how this database is designed to bring different classification systems together. With the authority data, we have defined the vocabulary of our knowledge graph, but not yet the grammar. In order to clearly define also the various properties, we need an ontology, our third fundamental concept. Wikidata follows a dynamic approach in this regard. The ontology here is very flat. That means that properties are structured just by a list of normative P identifiers, just as the Q identifiers we've seen with the entities. For example, the identifier P69 stands for the property educated at. In the example of Tom Jones, we see at the beginning of his datasheet that he is an instance of a human, that he can be seen in this specified image file, and that he is classified as a male in terms of gender. The Wikidata approach is very flat here, which has the advantage of easy usability, but the disadvantage is the threatening indifference or arbitrariness that is not precise anymore. In the field of art studies, the SciDoc CRM, the International Committee on Documentation Conceptual Reference Model, offers a more elaborated system. The advantage of SciDoc CRM is that it's a well-structured and precise ontology, which has the disadvantage that it is very complex and difficult to understand. But many academics love it precisely for that reason, which is why I wanted to mention it here. So let's see how these elements come to play in the De Jonge Wiki. While the structures described so far are suitable for expressing statistical data, in the humanities we also need the possibility to express possible interpretations and speculative theories, which is not possible with knowledge graphs. The De Jonge Wiki therefore offers a hybrid solution. On the one hand, there is an area in which considerations and theories in the sense of the humanities can be discussed. This area is based on the software Wikimedia, which is also the basis of the well-known online encyclopedia Wikipedia. On the other hand, there is an area for statistical information, which is structured as semantic data using the Wikibase software, on which also Wikidata is based. The purpose of the De Jonge Wiki is to document 25 years of research on building history on the Arenberg Castle in Heverlee. It is also the goal to incorporate and supplement new findings as simply as possible. In order to be able to specifically address individual elements here, the building complex was divided into different categories and subcategories. On the right, you can see how the name of a room is composed in the De Jonge Wiki. It starts with the abbreviation AC for Arenberg Castle. That is the entire area. The next level is MC, the main castle, followed by EW for the east wing, and 1F for the first floor there. Last element is today's number of the rooms. So all these elements, like coordinates, indicate the location of the particular room within the building complex. Here you can see the entry for a room in the front end on the left. That is the usual user interface. In this case, the article on the Salle Heraldique. At the top right, you can see an info box in which statistical data is given, such as information on width, length, height, or floor area, as well as the accessibility by other rooms, as well as a superordinate object of which the room is part of. This information is automatically imported from the datasheet in the background, which can be accessed by clicking on the De Jonge Wiki item function in the left sidebar. In this area in the background, the statistical information is created as semantic data in the sense of a knowledge graph and can also be edited there. Clicking on the bottom right takes you back to the front end. The basic structure of the De Jonge Wiki can be quickly and inexpensively duplicated and adapted to other research projects using the wiki freeware. In case of monument protection, it would probably make sense to define walls rather than rooms as the basic units. Statistical data could then be materials used, for example. At this point, I should perhaps mention that the De Jonge Wiki was an initiative that Max Christen from the LMU in Munich and I started out of pure curiosity and without funding. In the meantime, because of this project, I get invited to conferences like the Cultural Heritage and New Technologies Conference in Vienna in this November, while I have to apply for traditional humanities conferences with my actual PhD topic. And that we have now received funding for a student position for 2 years for the De Jonge Wiki project. I hope I was able to give you a first insight into the world of statistical databases with their knowledge graphs, their authority data, and their ontologies with this short introduction and make you hungry for more. If you want to know more about the topic, you can find more detailed information, especially on Wikipedia. I guess that's no surprise after this presentation. Thank you very much.